In section 1.6, we will be describing the product and the quotient rules. Up until this point in time, we have been working with some basic derivative rules, but the product and the quotient rules are going to be special because they involve problems where you have a product of x's with other x's, or a quotient. And a quotient is basically a fraction where you have x's in the numerator and x's in the denominator. Now, we had some sort of a product rule in the last section, but in that section, we described something called the constant multiple rule. It basically told us that if you have a constant times a function, then you just ignore the constant and you find the derivative with respect to x of the function. That was called the constant multiple rule, and that's different than the rule that we're introducing right now, the one that's called the product rule. The difference between the constant and the product rule is that the constant rule has a constant first, meaning some random number that we just write down and we ignore, and we just differentiate the function, and the function typically has a lot of x's inside of it, so we just do that after we write the constant. However, with the product rule, typically speaking, your problems are going to involve a set of x's multiplied by other types of x's. So we have to be a little bit more careful when we're describing the product rule because it has a lot of parts. Actually, this is the rule itself, and it has 4 pieces. Basically, the rule says if you have a product of two functions called f and g, then what you do to find the derivative is you differentiate the first one, but then you don't do anything with the second one. Once you finish that, you are going to add the product of the first one multiplied with the derivative of the second one. So in a way, the product rule basically takes turns differentiating the first piece and the second piece, and then multiplies it with the other second one that is not differentiated. So if you think of it like this, if I think of the f function being the first function and the g function being the second function, then my rule basically says, first, do the derivative of the first function, but don't touch the second one. And once you finish, do the derivative of the second function, but not the first one, and then add the two answers together. So when I do this problem, I'm going to be describing the 1, 2, the 1 prime, 2 prime, and then applying the rule with the 1, 2's, 1 prime, 2 primes, basically. So I'm going to label my first, my second function, and then do the derivatives of each, and then multiply them and add them up according to the rule. So I'll demonstrate that with the first example. Okay. So example number 1 basically says find, and it says d dx. So remember, d dx is notation for the derivative. So right here, they're saying find the derivative of all of these things. All right, so how do we go about finding the derivative of all these things? Well, first, how do I know it's going to be a product rule? I know that because of the product in the middle. That little dot makes it a product. So this is a product because of the multiplication. And it's a product of a lot of x's with other types of x's. So there are x's on the left and x's on the right of the product. So that means we are going to use the product rule for this problem. And in order to use the product rule correctly, I'm going to start by labeling my first function and my second function. So who is the first function? In this case, it's the x cubed minus 3x squared plus 5. It's whatever came before the product. And who's the second function? Well, it's everything that came after the product. So in this case, it's 2x cubed minus 5x. Now, once you do that, I want you to directly across from them, put the first derivative and the second derivative. So directly across from the old first and second function, put the derivatives of each one of them. So for example, what's the derivative of x cubed? It's 3x squared. What about the derivative of negative 3x squared? It's negative 6x. And the derivative of 5 is 0, so we're just going to ignore that. Now on the second line, the derivative of the second function, the derivative of 2x cubed is going to be 6x squared, and then derivative of 5x is going to be just 5 with the negative sign in front of it. Now, according to the rule, I'm supposed to multiply the 1 prime with the 2 and the 2 prime with the 1, and I'm supposed to add them. An easy, quick way to remember this is to draw an arrow that looks like this. Start with the corner that's called 1 prime and make your arrow go around. Notice I'm putting the direction. I'm starting here at the 1 prime and I'm going around and I'm finishing at the 1. And I'm just going to multiply according to the corners that this arrow describes. So the opposite corners get multiplied. And once you're done, you're just supposed to add in the middle everything. So multiply the 1 prime with the 2, and that gives you the first part of the rule. Then multiply the 2 prime with the 1, that gives you the second part of the rule. And at this point, you'll basically add them up and you'll be finished. So going back to the original question, the derivative with respect to x of the quantity x cubed minus 3x squared plus 5, all multiplied by the 2x cubed minus 5x is going to be equal to, again, according to this, 1 prime times 2, so 3x squared minus 6x gets multiplied with the 2, so that's 2x cubed minus 5x. Then we're supposed to add the product of 6x squared minus 5 with the x cubed minus 3x squared plus 5. So again, this portion right here represents the 1 prime. This represents the 2, meaning the second function. Whereas this one right here represents the 2 prime, and this one right here represents the original first function. And again, the order right here is different than the one is described in the rule, but it's multiplication, so it doesn't really matter. And notice how I'm putting a plus between everything. That's basically the derivative. At this point in time, I'm going to have to clean it up a little bit and FOIL everything and combine like terms, but that's, that's because they want me to simplify the expression, typically speaking, and find some other information from the problem. But this is already the answer. So if you stop right here, I mean, this is kind of correct, but it doesn't look really the best way it can. So I'm going to FOIL everything. I'm just going to do this, basically, FOIL everybody, and figure out what the answer is. And now I need to add every like term. And there we have it. The derivative is 12x to the power 5 minus 30x to the power 4 minus 20x cubed plus 75x squared minus 25. And that's the final answer, so we can just put a box around this and we're basically finished. So I'd like you to try the second one, and I'll give you the answer in another video, but I want you to try the second problem that you see on the bottom of the screen right now. See if you can get this one done, and see if you can find the derivative and simplify the expression, add like terms, and so on. It's going to be very, very similar to the problem that I just did.